Hello, everyone. Welcome to this workshop. Good morning, good afternoon, and good evening to the developers from all over the world. And this is Frank. This is Frank, the developer relation engineer from Chainlink Labs, and I'm really excited to be here and to introduce the very exciting, the use case based on the AI agent and the Chainlink Oracle network to you. So I hope you can learn something from this workshop. Okay, so before we start, good morning, GM from India. Good morning. Yeah, so in this workshop, we have 3 sessions. So for now, I will give a very brief introduction about this workshop, what we're going to do. And after that, we invited a developer relation engineer from Avalanche Lab and Owen will go through, will guide you with Avalanche blockchain basics and how you can do AI, do the decentralized applications on the Avalanche. And after that, I will give you a demo to show like how to build a AI agent with a framework Eliza, and then use the Chainlink Functions to just serve as a bridge to fetch the data from the Web2 centralized database and then write it into the smart contract. And then we will also to just use Twitter as our client to collect the input from the users. So in this project, you can just allow your users to input some natural language input. And for example, like, please give me some gift to the address with a gift code, blah, blah, blah. And then this AI agent will just get this input and analyze that, and then to trigger the actions, to just call some functions from the smart contract, and then finally give the gift to the address. Okay, so I know that AI is pretty popular in this year, so people all want to learn more about AI, want to learn more about what we can do with AI on the Web3 with blockchain. So actually, I think that for AI, there is a very important use case in the Web3 industry is that the AI can serve as a abstract layer. How we can see that? So you don't need your users to just send the complicated transactions to the specific smart contract and do something they want. You just can allow them to write some natural language, and then they can just send a very complicated transactions and then do some transfer, do some function call on the smart contract. It will bring more and more users and to this Web3 world, and people can just use it as a Web2 app. And AI agent here can serve as a very smart brain as a backend for the decentralized application. And in this project, we'll definitely do that. So before we start, I just want to let you know that we have a Gitbook here, and I will paste the Gitbook link in the chat box. So for this Gitbook, we have all the codes and all the steps. And if you want to follow me in this workshop, it's good. And if you want to do it yourself after workshop, it is also good. And in the first page of this Gitbook, you can see that we introduce what we will do in the workshop, and what is the AI agent, and what is the AI agent framework we are going to use, Eliza framework, and also we are going to use Chainlink Functions to bridge these two, the centralized and decentralized world together. And before you're doing that, you also need to prepare this in your environment. You need to have the Node.js and the npm installed in your machine, and you also need to get some test tokens from the Avalanche and the Chainlink on the Avalanche testnet, which is called Avalanche Fuji. And you also need to LLM API key that can be provided by any AI you like. For example, like a Google Gemini, that is free. You can get a Google Gemini API key here for free. And also you can use the API key from the OpenAI. And because we need to save some data in the database, and you need to have a Supabase account. The Supabase is like a lightweight version of the Firebase, which is a light version of the Amazon Web Service. So you can just create a free account and create a database, and we need to save some data in the table. Okay, and finally, you need a Fuji RPC URL, and you can get it from the Infura or Alchemy. That is all free. And after you get this prepared, we can start our coding. And you'll need to use everything I listed here in the workshop. Okay, so next, let me just pass to the Owen from Avalanche Lab, and he will introduce the Avalanche network and how you can work with Avalanche.
Hello. Good morning. Good morning from New York. How's everyone doing? I got the chat open on the side. See Berlin, Venezuela, UK, Athens, Greece. How's everyone doing? Sorry, just a bit of a warning. I woke up a bit sick this morning, so if my voice gives out or if it's a little shaky, then that is the explanation. But yeah, happy to meet everyone. I'm Owen. I'm a developer relations engineer here at Ava Labs, working on Avalanche. Been at the company for a little less than 7 months now. And before that, I worked at Polygon for a little shy of 2 years. A GM from Texas, Pakistan, India, Kenya, and we are global this morning. NYC, respect, Pakistan. Awesome. Just want to hop right into the presentation. Perfect. Awesome. So today I'm going to be presenting pretty much a high-level overview of what Avalanche is. Just to get a show of hands, who here knows what Avalanche is? Maybe just put a 1 in the chat. If you are somewhat familiar with Avalanche, I've heard of it before in passing, something like that. I don't know what the delay is, so hopefully, okay, I saw 1, so I'll continue. So a little bit about myself. My name's Owen, developer relations engineer at Ava Labs. I graduated from NYU with a degree in computer science and a minor in American Sign Language. Like I mentioned, I worked at Polygon for a little shy of 2 years as a solutions engineer. And now I'm currently a developer relations engineer at Avalanche. Some of the stuff I've worked on at Avalanche within like my last 6 to 7 months, my team maintains the maintains the build.avax.network website. I also did some work on HyperSDK, mainly around like the HyperSDK starter kit, which I'll talk about more later. Telegram mini apps for Avalanche, RIP, don't exist anymore, sorry. AI agent for specific DevRel activities I've worked on. And then also, if you guys are familiar with Avalanche, you may be familiar with like the ACP 77 / ACP 99 upgrade. ACP stands for Avalanche Community Proposal. So these were 2 network upgrades that were pretty recent. I was kind of one of the first people to glue the upgrades together and kind of put them into a functioning environment. Yeah, so a bit of overview of what we're covering today. Avalanche overview will be about 10 minutes. I'll briefly go over some of our grant programs, specifically like our InfraBUIDL AI program, which will be about 3 minutes. And then after that, I'll just be showing off different projects that use Avalanche. Does that sound good to everyone? Awesome. So what is Avalanche? At its core, at the very high level, Avalanche is a network of networks. So this picture that I'm showing you right now is all blockchains that live on Avalanche. And I actually believe there's a bit more, but these are just the ones that this website, snowpeer.io, index. So there's a lot of different unique application-specific blockchains built here. So obviously we have the Avalanche primary network. And if you're a user of Avalanche, and when most people talk about Avalanche, they're actually talking about the Avalanche primary network. So if you're like trading on LFJ or Pharaoh or any of these Avalanche dexes, or buying tokens, chances are you're touching the Avalanche C chain, which is part of the primary network. There's a lot of other types of application-specific blockchains, though. So, for example, Gunzilla is, if you've heard of Off the Grid, they were the first crypto console game to come out. And it's cross-platform. All the cosmetics and weapon skins are NFTs in the game, and they have their very own L1 to do this. There's some more fun projects like Cocknet, which is actually a permissionless proof of stake meme token essentially with VRF baked into the validator set. So that's also interesting. But you can see some more kind of like odd things here where it's like we have 3 chains, Remedy, that all have the same logo, all have the same name, but all have different, very unique and like purpose-built, I guess, applications or purposes. So one of them is for compliance, one of them is purely for transactions, and another one is for identity. So I'm not going to touch on every single L1 that's here, but you can kind of get a high-level idea of what Avalanche is. To be a bit more specific, a bit more technical, so Avalanche is the primary network, which is this thing in the center here. And it actually consists of 3 different blockchains. So starting from the left, we have the exchange chain. And this chain can simply create, it doesn't have any notion of smart contracts. It can simply create assets and exchange assets. So you can like mint an NFT, trade it to someone, that's it. There's no DEX, there's no swapping. It's simply minting an asset and exchange and transferring an asset, right? And I have a little caveat down here that the X chain is not very popular today, which it isn't. And then on the right-hand side here, we have the Avalanche C chain, which stands for contract. And this is your run-of-the-mill, I guess not run-of-the-mill, a bit faster EVM chain. So it's high throughput, low transaction cost, fast time to finality, and it's essentially Avalanche's version of the Ethereum virtual machine. And then this middle part here, which arguably is what makes Avalanche so powerful and unique, is the platform chain. And so the platform chain doesn't have any smart contracts either. It actually, you can think of it as like a phone book or a registry of all the validators in Avalanche. So you can see these 3 things here. It says coordinates validators and creates subnets. I'm going to touch on that a bit more later, but you see this platform chain is responsible for registering more validators to create these things called subnets. And that's this custom chain 1 and custom chain 2. So at the end of the day, when you put all this together, it looks like this, right? You have a primary network of validators, and then within this validators, within the primary network, you have different subnets that are comprised of the same validators. And it's important to point out that each validator in this set, in the primary network, has to stake 2,000 AVAX. And so a big upgrade that we did in December was ACP 99, also known as the Etna upgrade, also known as Avalanche 9000. And this kind of moved the subnet model to a legacy model, I guess you could say. So instead of Avalanche only having subnets, we now allow for any sovereign validator set to come in and register with the primary network. And you may be asking, okay, like why would I want a sovereign validator set to register for the primary network? There's a few different reasons. One of them would be compliance. Like you don't want to have to validate the primary network. You want to control your own blockchain yourself, set your own rule and permissioning. Another reason is native interoperability of Avalanche. Because we have this P chain known as the platform chain, we have native interoperability of all Avalanche L1s out of box. I'll show you a bit later, but it's as easy as calling a contract. And so a big part of this upgrade in December, we removed the 2,000 AVAX staking requirement for primary network validators. And now, if you want to be an Avalanche L1 is what we're calling it, subnets to L1s, of your own sovereign validator set, then each validator only has to pay a 1.3 AVAX per month fee. So if you look here, so there's 4 validators in this picture example, right? So each one of those would pay at 1.3 AVAX per month. I guess I can stop here and see if anything is, if there's any questions immediately. DFK, one of my favorite applications. I love the DFK guys. I see a lot of ones from earlier. See an Avalanche ambassador in here. That's awesome. Chainlink supports Solana. I don't know. That's not a question for me. All right, moving on. So the reason why we did this is essentially, well, there's a lot of different reasons. One of them is compliance, like I mentioned earlier. Another one is like shared resources. So a problem with this previous model is that you have some validators that are validating 3 different blockchains, right? And that can be somewhat compute expensive. So if it's a sovereign network, you get to control the validator set. Validators can be as expensive or as cheap hardware-wise of what you want. And when you combine all these L1s together and they have native interoperability, you can achieve a massive combined throughput of subnets / L1s. This label's a bit wrong, but also has an incredibly short time to finality. To touch on that even more, so these blockchains aren't just like cookie cutter blockchains. You have on Avalanche complete customization of your virtual machine. So this kind of diagram that we're looking at right now is the smart contract level, the execution level, then the consensus level. So Avalanche Go is our Golang library that essentially links all these components together and pretty much is the consensus engine for Avalanche. So if you're a developer and want to launch your own blockchain, you can take the EVM, you can take MoveVM, you can take Wasm VM, you can take the Solana virtual machine, and we have another SDK that's specific for building blockchains called HyperSDK, which I'll touch on a bit more later. But quite literally, all you do is pick your virtual machine, plug it into Avalanche Consensus, and you're good to go. So the HyperSDK part I mentioned, I briefly touched on this. HyperSDK is pretty much application-specific blockchains. Build your application logic specifically into the virtual machine itself. And when you do this, you can achieve insane throughput, insane TPS, because you don't have the bloat of a general purpose blockchain, right? Like you don't have smart contracts. You can have smart contracts, but you don't necessarily need to include them in your HyperSDK VM. So this is probably what would be most interesting to folks here. This is Subnet EVM. So this is the Ava Labs maintained version of Ethereum. You can kind of think of it as our EVM++ or EVM equivalent. And this is honestly my favorite part of Avalanche. It gives you complete customization over your virtual machine, over your Ethereum virtual machine. So you can make basic customizations as like just increasing the gas limit per block to give it higher throughput. But you can go really deep into this code base and change absolutely anything that you want. And if it builds, then you can deploy it. So what this means in practice is that you can use any custom gas token, any custom staking token. You could use pre-existing ERC20 tokens as your gas token. You can do the same thing for staking tokens. And we also have a notion of precompiles that we expose to the developer. Some of the default precompiles would be like a transaction allow list. So only certain addresses can transact on the network. Another one would be a contract allow list where only certain addresses can deploy contracts on your network. And then you can write custom precompiles. And just to back up a bit, a precompile is, you can think of it as a Golang function or a Go function that's built specifically into the VM, and you can interact with it as if it's though a smart contract. So some examples of custom precompiles would be like ZK verification or fully homomorphic encryption. But again, if you can build it, then you can deploy it. So touching back on the Subnet EVM and like the Avalanche native interoperability, we make it extremely easy for Solidity developers to cross-chain communicate with other Avalanche L1s. So you see a little like code snippet here on the left where it's literally just a Solidity interface that says send cross-chain message. You put some inputs of the chain ID, the address that you're sending it to, and like a gas amount and the message. And that's it. That's all you have to do. And then underneath the hood, so this would be your application, your cross L1 dApp. It talks to the Avalanche interchain messenger, and then that will talk to the warped precompile, which is part of Subnet EVM, and then that will get pushed over to the other side. And it's the same thing for receiving a message. You have a nice interface in your Solidity contract that will say receive teleport message, put whatever logic you want in there. The relayer will deliver the message. ICM will confirm it works with the precompile, with the warp precompile, and then it will get processed to your dApp. Maybe this is a bit too involved for this workshop, but the TLDR on the warp precompile is it's included within Subnet EVM. And what it does is it will take a signed message of BLS public keys, and it will pass it, it will check it against the current height of the P chain to make sure that A, all the signatures are valid, and B, all the signatures that are included in the set actually came from the blockchain that it said it came from, right? It's not just like random people delivering a message. And then I think we're getting close to like the end of my Avalanche overview. So if you guys are tired of me and like say I want AI stuff, then sorry. So this is ACP 77, which I mentioned earlier, kind of goes hand in hand with ACP. Actually, this is ACP 99. This is the typo. This is ACP 99, not ACP 77. So ACP 77 was the Etna network upgrade, which enabled these very cheap L1s to get launched on Avalanche. And ACP 99 is actually the contract standard that lets you define custom rule sets for your for your L1 from ACP 77 in Solidity. So if you look here on the left, we have it's an abstract Solidity contract named ACP 99 Manager, and you have all these different events, and you can kind of see some of the functions down here at the bottom. But if you can define whatever logic you can define in Solidity, you can define it for your validator set. So that means proof of authority, either with like a single owner or multi-sig owner, proof of stake with an existing ERC20 token, a native token, Bitcoin, USDC, literally anything that you can think of. If you can define it in Solidity, you can do it. And again, this is all powered by the same concepts on these last two slides, which is Avalanche ICM. And if any of this sounded interesting of you at all, I highly encourage you to go check out build.avax.network. This is kind of our central hub right now for everything Avalanche. You can see on the top, we have documentation, Academy. We have some web-based tooling to spin up L1s and manage L1s. We have a grants page. Go check out that. I'm going to touch on that here in a second. Different integrations, hackathons, front-end development kits. Everything you need to do to get started with Avalanche is on this website. Awesome. So now we're actually getting towards the AI stuff, finally. So I'm going to introduce the InfraBUIDL AI program. I'm going to give it a second here if people want to scan the QR code with their phone. And also go through the questions real quick. Do validators get paid for staking 2,000 and keeping a validator running still? Or do they have to pay to keep a validator running? So if you're a primary network validator, it's a 2,000 AVAX staking requirement. And so staking doesn't mean that you're paying the fee. It just means that you're willing to lock up those tokens for a certain amount of time. So you actually do earn an APY on your AVAX when you stake it for the primary network. Mainnet validators get staking rewards for staking AVAX. Yep. Only L1 validators have to pay 1.33 AVAX to run as validator, but everyone can have its own reward. Exactly. Yeah. So every L1 validator with this new upgrade has to pay 1.3 AVAX per month. And that fee is just outright burned. It's not rewarded to anyone. And then the L1 is responsible for kind of like defining and creating their own reward mechanism. So, right. Awesome. So what is InfraBUIDL? So InfraBUIDL AI is up to a $15 million in funding for innovative AI projects that touch the Avalanche blockchain in a creative way. So this can be a lot of different things: chat agents, meme agents, trading agents, DeFi agents, toolings for agents, social influencer and agents. Really, the scope is very broad, and that's intentional. If you're building an AI project on Avalanche, you should be applying to this fund. And yeah. So what's kind of fun about this whole InfraBUIDL AI project is that we actually introduced a AI-powered committee member of, I think it's of 6 people. This AI has one of the board seats and also one of the votes. So I'm going to show you a demo here just in a second. But what this agent does is it's an Eliza OS backend that's acting as though it's a VC, and it's also trained on all of the Avalanche documentation. And then for each of the other committee members on this InfraBUIDL program, they have this browser extension that they will open up anytime they're in a relevant meeting or watching a relevant pitch deck or something like that. And this browser extension will transcribe the audio from their browser and send it over to the Eliza OS backend. That again is acting as a VC. And the VC will start asking questions if it's a relevant project to InfraBUIDL and if it should get its vote for at the table. So hopefully this demo works. I don't know if the audio is going to work, but we can just do kind of
right, everyone. Next up, we have Ash.
Hello, everyone. I'm Gauthier from the Ash team. I'm here to introduce Suseko.
Yes,
Subnet is the restaking protocol for sovereign networks. When we talk about sovereign networks, we mean proof-of-stake, app chains, and layer ones, basically any other decentralized network that will rely on one of those at its core. All those networks will face the same problem: how to bootstrap their cryptoeconomic security. Meaning,
I'll mute it for now, but if you give it a second here, so you see the browser extension is transcribing the audio. You can see it right there. And then in a second here, it's going to pipe it over to the terminal on the right-hand side and start kind of processing these transcriptions and asking questions about the project. Were you guys able to hear audio? Audio was good. Okay, let me turn it back on then.
Introduction of shared security, which allows one network to land and share the proof-of-stake security of another one. More recently, EigenLayer introduced restaking. Through restaking, stakers of a strong proof-of-stake network like Ethereum can opt in to secure other decentralized services, called AVSs for actively validated services.
So you can see is, I think this is Leo from Ash presenting at one of the last Avalanche summits. So this browser extension, again, is transcribing the audio from the video, and it's sending it over to an Eliza OS backend. And you can see kind of the questions that it's asking being in red, and then it's answering itself based on the info from the transcription in green. So like what problems being solved, bootstrapping crypto economic security for sovereign networks, AI mentioned, no, target audience, L1 builders, validators, DeFi projects, so on and so forth. So you can imagine, skip out of this now. Awesome. Yeah, so this is Alfred's Twitter account, actually. So he will be posting regular updates based on the information that he learns about. I added a QR code in case you want to follow him. I think that would make my coworker very happy. How does this project leverage Avalanche? So Alfred, I'm going to touch on some projects that actually touch the chain. Some of the projects that my team works on specifically actually don't touch the chain at all. And they're more so like, I guess, utility or like kind of assistance rather than like going out and performing actions. Awesome. So this is actually a project that I've been working on. His name is 0xHal, and again, it's an Eliza OS agent. And there's nothing really unique about HAL besides, I guess it's really good to showcase how powerful agents are and like LLMs can be for different roles across the company. Me specifically, as a developer relations engineer, has been extremely helpful. And pretty much all HAL is, it's again an Eliza OS backend. And I just have like a nice data pipeline that will go through and scrape all of our documentation, all of our GitHub READMEs, and just save it into its knowledge base essentially, right? So on the left here, that's HAL's Twitter account. You can see that it goes through and bull post Avalanche all day, which is nice. But then he also has a Telegram client. So when I'm in calls randomly sometimes and I need a quick link to something or I need to explain something, I can just kind of talk to HAL real quick. I'd be like, hey, give me links to the Avalanche community proposals. And he spits out some BS, but he does give me the link to the ACPs. And I'm like, okay, well, tell me about some actual ACPs. And he's like, by the way, ACP 125, ACP 23, ACP 62, ACP 113. And these are all actually like really accurate to the documentation that it was trained on. I'm like, hey, can you give me, ACP 62 sounds interesting. Can you give me a link? And it go ahead and gives me the relevant GitHub link. And then also I've kind of expanded this into our Retro 9000, which is, I guess, like a grant program, but also our developer support channel. If you're in there, then you probably have ran in with HAL before. But when I'm AFK, he's kind of the person managing the chat and answering technical questions. So you can see in this example, someone had a question, hey, is there a common bridge between Avalanche, our own chain, Avalanche, let's say other EVM chains? Let's say like I want to go from ETH from Polygon to my own custom chain. How can I do that? And HAL was actually very accurate in his answer. He was a bit wrong with like the technical, like the proper names for it. He says use the Avalanche native bridge, which he means by that ICM between your L1 and C chain. So that is 100% accurate. And then integrate with an existing bridge protocol like Layer 0 or Axlar if you want an additional hop to, let's say, Ethereum mainnet or Polygon or any network that's not an Avalanche L1 and has native interoperability. Cool. Let me take a quick breather real quick. Let me get some water. And then these are some more community projects that are leveraging AI and Avalanche. Awesome. So if you are on Avalanche, there's no way you have not heard of the yellow cat from Wyoming. So this is the yellow cat DAO, and it has a lot of fun artwork, AI generated based off this little mascot right here. It also has a Twitter account. I believe if you scan this QR code, it will take you to the account where the AI agent will be tweeting from. But this is like, honestly, like one of the, I don't want to say first, but one of the first like mainstream AI projects on Avalanche. And it's simply just a yellow cat that trades across chains and will bring back the profits to Avalanche. So the screenshot that you're looking at here is actually like the P&L for this AI agent that's trading on Solana, Base, and I think Arbitrum. And then anytime it gets profits, it will immediately bring them back to Avalanche and buy its own token with them. Somewhat dumb, somewhat novel, but I think it's fun, and the artwork's really fun. Project that got onboarded relatively recently, actually, like I think they had their announcement yesterday, is a company called DAppThat, and they make it really simple to create kind of 0 to 1 or 0 to 100 DeFi applications, or I guess dApps would be a better word, all AI generated. So you see kind of this picture, you define your requirements, you generate your code, and you can instantly deploy it. They're kind of in like the beta mode right now, but they are heavy Avalanche. They love the Avalanche ecosystem. You can kind of see some of their demo apps over here. Staking pool, a whale company. So this AI agent will make both the smart contract, it will deploy it to the relevant network, and then we'll also create the front end and we'll attempt to link the two together. I guess the linking of the front end and the actual deployed contract right now is a bit glitchy, but I'm hopeful that in the future we'll get these numbers up to 100% AI generated. Awesome. So again, I'm just kind of like speed running these Avalanche community projects right now. And if you're part of the Avalanche community and you don't see your project listed here, I'm sorry, I couldn't get to everyone. But this is YieldYak on Avalanche, which is a native DEX, or not DEX aggregator, a native yield aggregator for DeFi protocols. So if you go to yieldyak.com, I believe it is, that you'll see what their website is. But they actually built a plugin for Eliza for Avalanche. So you can send and receive tokens on AVAX, you can deposit to the YieldYak protocol, any of the different strategies, so on and so forth. So some of these screenshots here just to show like, oh, he's swapping tokens, swap 1 USDC for the Joe token, approving USDC, swapping USDC, like basic stuff. And then down here, it's like depositing to a YieldYak vault to earn YRT token. Yeah. But I would follow Yakman9000 on X. He's a great guy. And then this is also something else that they're working on that I wanted to highlight in this talk today. They're actually working on a vault manager for YieldYak, an AI vault manager for YieldYak. So this is just kind of like the high-level architecture. You can see that it gets all these different types of data from different resources: yield, risk, platform docs, social posts, instructions, on-chain stuff. And then it'll like make educated decisions and then actually perform operations on this manager smart contract. And I believe the multi-sig, which is in the next slide, has to pre-approve instructions that the agent can take. So in case of hallucination or something goes wrong, you don't end up losing funds, right? But you can kind of get a more detailed overview of how this whole like approval system works for the instructions. It uses Merkle proofs. I believe I have maybe 1 or 2 more projects, and then that'll be it for me. Awesome. Kite AI. This is honestly one of my favorite projects. They have their very own L1 for AI agents. So you can kind of think of this as the Hugging Face on chain. I guess that's the best way to put it. So they have like an open marketplace for data sets and AI agents, so you can discover and monetize different data sets. Down here, customizable subnets. So they have different data pipelines that you can tap into for privacy and computational performance, kind of like for more specific and targeted AI use cases. And then obviously one of the best benefits of blockchain is incentivizing and rewarding your users. So they have ownership and reward models where you can control pricing and receive rewards for your contributions to the platform. If you have time today, I highly recommend go to app.gokite.ai or just look up kite.ai and you'll find them. They are doing amazing stuff on Avalanche. They're live on testnet on their own L1, and they've been very pleasurable to work with. So, and yeah, I think that's about it for me. I hope I didn't go over time. I hope I'm not too under time. But I think this QR code goes to my Twitter account. If you want to drop a follow, it's greatly appreciated. But yeah, thank you guys for having me out today and letting me talk about Avalanche and some of our AI initiatives and projects. And yeah, I actually took a Chainlink hackathon when I was in college still. So I was like very much in your guys' seats not too long ago. And now 4 years later, here I am still working in the industry, presenting on the opposite side of it. So thanks a lot.
Thank you, Owen. Thank you. Very good presentation. And thanks for taking part in the Chainlink hackathon. And we also have a hackathon this year, and hopefully people can come to this hackathon. We will have the AI track, definitely, and the DeFi or GameFi track for all the participants in the hackathon. Thank you very much. Yeah, so after the perfect presentation from the Owen, let's just start our journey to build AI agent. So at first, I just want to let everyone know what we are going to build today. So in this workshop, we are going to build a project. And in this project, user can effortlessly receive an NFT gift by simply reply the tweet under tweeting their request. It's like when you want to get an NFT, and like before, you need to get a wallet, and then you need to find a smart contract address, and then compose a transaction and send this transaction through the RPC service, and then you can get a NFT under your address. But with AI, we use AI agent as an abstract layer to just allow the end users to just input the natural language, and the AI agent will analyze every natural language request it received, and then to just decide if an action needs to be taken or not. And if based on this input, the AI can see the address and can see the gift code, then it can use the information in this natural language and to compose a transaction and send this transaction on behalf of the users. And this is what we are going to build today. And in order to give you some insight about the project, I just show this very high-level architecture. And in this architecture, we can see that there are 3 parts. In the first part, it is called a front end with AI agent. So in the front end, it is not a website. We use Twitter as a front end. So I think you have already seen some bot or some AI agent on the Twitter, then the Twitter will speak something, and we call it the front end. And with this front end, you don't need to build your own website with HTML and CSS, and you can just use any social media like Twitter or Telegram or anything you want as your front end. And the users can just create a dialogue in this social media and to input whatever they want to do in the natural language. And that is the front end. So in this project, under this front end, the user will just input their whatever they want, and then the LLM, which is employed by the framework called Eliza, and will just receive this text and analyze it. And if there is action need to be triggered, the framework will trigger a action. So we have an action called get gift in our workshop. So in this action, it is used to call the functions in a smart contract and then mint an NFT. But before that, we need to check if the gift code provided by the end user matches the gift code we saved in the table. And this is for the front end. And the second part is the backend. The backend is simply the centralized database we used in this workshop. We choose to use Supabase because the Supabase is very lightweighted and it is easy to create an account. And then you don't need to pay any fee. You just create a free account and create a database, and then you can have your tables under the database. And maybe your question is, why do we have the database? Why do we have the centralized database in the Web3 decentralized application? Well, the reason is that usually in the design of the decentralized application, you just cannot drop everything on the blockchain, right? Because using blockchain is very expensive. Every transaction, every interaction your end user is using the blockchain smart contract, they need to pay the gas fee. So in my opinion, I think maybe for the asset-related data or very important functions, we can save this kind of stuff on the smart contract on chain, and it's transparent and it's tamper-proof. But for the business logic, like the status of the variable A in this time point A and the status of the variable B in the time point B, this ton of the information will be saved in the database. And in the database, when this data is need to be used, we can have a third-party service called Oracle to just bridge the data from the Web2 world to the Web3 world. So that is where Chainlink comes to play. So Chainlink, I think you know Chainlink, right? The Chainlink is a decentralized Oracle network, and based on the decentralized Oracle network, the DON, we provide multiple services like Chainlink Functions, Chainlink Data Feed, and Chainlink BUF, and CCIP. And in this, one of the services is called is this one, the Chainlink Function. The Chainlink Functions is a service where you can execute your JavaScript code in the Chainlink Functions environment. And every your code is executed, it will be executed by multiple nodes under the Oracle network. So if you want to get a data from the database, and the Chainlink Oracle node will get this data from the database, and every node will do the same thing. It will get the data. And then after every Oracle node collect their necessary data, they will do something called a consensus. And they will aggregate this data together and then do some verifications, and finally will return this data back to the smart contract on chain. That is what Chainlink Functions doing here. And the reason we want to use the Chainlink Functions because if you have some service here to fetch the data from the database to the Onchain smart contract, it is hard to be trusted, right? But with the Chainlink Functions, the data saved here, when it is fetched from the database and put into the Onchain smart contract, it will be done in a very decentralized manner, because every different node, every single node under the decentralized Oracle node will do it independently. And so it is very hard for the malicious attacker to control this data flow. So that is the reason we use Chainlink Functions here. And after that, the third part is a backend for the asset. That is something, that is the fancy way to say the blockchain. So we have our smart contract on the blockchain. And this smart contract have two functionalities. The first functionality is NFT 721. That is an NFT smart contract, which has functionalities like mint, burn, transfer, allowance, transfer from, this kind of functions. And the second functionality inherited by this smart contract is Chainlink Functions, because we need to send the Chainlink Functions request from this smart contract, and then the DON will receive the request from the smart contract and do its own job to fetch the data and then match if that data to verify if that data matches the data provided by end user. If the end user input the correct gift code we saved in the table in advance, then the DON will return the result and the new NFT will be minted. So the whole flow is like when the user input something like, hey, please give me a gift to the address 0x123 with a gift code like a KYQ123, and then this transaction will be sent to the function consumer smart contract on chain, and the function consumer smart contract will just send a request to the Chainlink functions. The Chainlink functions then will get the data from the table and match to check if the data sent by the smart contract matches the data saved in the table. If these two pieces of the data matches and the function will return the result back to the smart contract, and the smart contract will mint an NFT to the user's address. Okay, so here is the whole picture. So I will wait for several seconds to see if you have any questions. So if you have any questions, just drop your questions under the chat box, and I will answer that. Oh, my voice is not clear. I'm sorry about that. Let me check if I can change my voice better. I'm sorry. The audio and automatically adjust the mic volume. Yeah. Okay. So I think it should be better now. I'm sorry for that. And yeah. And another question from Ik is Eliza a wrapper for OpenAI? Yeah, you can see that. Let me just briefly introduce what is Eliza. So in Eliza, as far as I know, because it's a quite new framework, and I am just a no more user of this framework. So in my opinion, the Eliza framework have three things. The first thing is a client. So the Eliza need to wrap the client, and they can provide the client like they can provide the clients like a Twitter, Telegram, Discord, and even the LinkedIn, Facebook. So if you input your messages through this social media, through this client, and then this message can be received by the Eliza. And this is the first part, the client. And the second part is as you mentioned, the OpenAI or Grok or any like LLM. And this LLM is the core or is the brain of the Eliza. It depends on which LLM you connect with Eliza, then your input from the client can be analyzed by this LLM. For example, in this workshop, we listed here, we can use the Google Gemini API key. And also, if you have OpenAI key, it is also okay. And because we list the Google Gemini API key here because it is free to use for the first time. So if you were the first time for you to build an AI agent, you can apply for a free key in the Google Gemini. But you can use whatever the LLM you like for your Eliza. Eliza is just a wrapper to provide a client and also connect the input data to the large language model you select for the Eliza. And the third part for the Eliza, which is very important, is Eliza can define the actions. So what is actions? Like you need to define what this AI agent can do. For example, in this workshop, we want this AI agent to send a transaction to mint an NFT, mint a gift. So I will define a new action called get gift or mint gift. But if you want to build an AI agent to help the user to create an image, and you can create an action called create image or whatever you want. So for the client, for the LLM, and for the actions, these three things are very important in the Eliza. So with the Eliza, you can use this framework to combine these three things together to create your own AI agent. And I don't know if I explain it clear or not, because it's a big topic. Yeah. We can use this wrapper to easily build an ERC20 token airdropper too, right? Yes, correct. and you can create a new action. And in this new action, you can name it as a airdrop USD20 tokens to the address, and you just need to modify the code for the action, and you can also do that. Okay, the question from the Harriet is, Eliza works with Onchain. For this question, to be honest, I don't know. I think kind of the Onchain is, and the Eliza is kind of the competitor, but I cannot promise that I'm correct on this point, because both of them are the framework for the LLM, right? So you can use Onchain or use Eliza or use any other framework to create your AI agent. And for this workshop, I used Eliza. The reason is that the Eliza has a library for the Ethereum. So I can use Eliza to send a transaction to the Ethereum EVM chains like Avalanche. And that is the reason I'm using the Eliza. And another question is, can agents make mistakes? Yes, it can make mistakes, but it really depends on the prompt you're using. So as we know, when we talk with the AI, we need to write some descriptions, write some requirement, and the more you write, the more clear the AI will know what you want to do. So if you just tell him, hey, please send out transactions for me, and the AI will not know what transactions it need to send. But if you tell them, please send the transactions, and the transaction would be like this, and the destination of the transaction is a smart contract with address 0x123 or something like that, and that will make the agent do that correctly. And without the clear instructions, without a good prompt, the AI agent can make mistakes, correct? Okay, so let's move on. This is just a brief introduction about what we are going to do, and let's go to the first step, to create a table in the Supabase. So here is what we are going to do, the Supabase. And in order to save some time, I have already created my table on my Supabase account. And before we're doing that, the first question is, why do we need to save data in the traditional databases? Well, for this question, we just talk about it, right? Because, oh, I'm sorry. So because we cannot save everything on the smart contract because the blockchain is expensive to use. So for the Web3 decentralized application, we can save some business logic data. The data will be updated frequently in the database. And then we save some data that is not supposed to be changed frequently, like asset-related data or some very important actions in the smart contract. We can save this kind of data on the smart contract, and that is why we need to save the data in the traditional database. And another reason is that if you save the data on the blockchain, well, the blockchain is transparent and it's tamper-proof. And if you save the data on the blockchain, everybody can see your data. It is no privacy. I know there is some technologies to keep the privacy of the data on the blockchain, but it is harder to use. So no more way to save the private data is still in the centralized database, and we can save some data on the database and also save some data that is supposed to be to everyone on the smart contract on the blockchain. Okay, in the Supabase, let me open that. Here is my Supabase. Let me zoom in. So if you never use that, you can go to the supabase.com, and after you go to the supabase.com, you will go to this page, and you need to create a new organization here, like this one. I have already created my organization. This is my name, and this is my organization settings. And you need to create a free version of the organization. That there is nothing special. You just need to create an organization, and then you can create a databases under this organization. And then let me go to the organization. And in the organization, you can have the project. And in the project, I have already created a new database. It is called, and within the database, I have a table called gifts. So if you are familiar with SQL, it is very easy to use. And if you never use the SQL, like select or update this kind of stuff, you can still create your table in a UI. For it provides SQL editor and a table editor, and you can click this button to create a new table. And this new table will be used in our workshop. And for now, I have already created my table, and this table is called gifts. It's used to save the information about our gifts. And let me open that. So within this table, let me zoom in. We have 3 columns. I also mentioned the columns in the Gitbook. You can check the information about the columns here. So the first column is auto-generated by the Supabase. It is the primary key for the record. And the second column is the gift name. For this workshop, I just created 3 fake gifts. The first one is a 1 month premium subscription, and the second gift is a 50 discount, and the third one is a $100 discount. So you can have these 3 types of the gift to give your consumers, to give your users. And in the third column is the secret code. So this code should be private and it should be secret. And you only grant gift to the users if the user can just see the correct gift code. So in the Twitter, the user will say, hey, can you give me a gift with a gift code CZ9ODVG, something like that. And you will know that this is correct, and you will give him the gift. But if the user cannot see the correct gift code, they just cannot get the gift. And that is the reason this secret code should be kept private. And we see these 3 columns in our table, and we are going to use this table to read this table when the new request come from the user, come from the Twitter. And the AI will trigger the function, and the Chainlink Functions will read this data from this table and match if that is to check if that matches the gift code from the user. Okay, and when you finish this table, and there is one thing you need to get. This is just the process to create an organization, and then to create a new table. And after the new table, you'll need to create 3 columns, actually 2, because the first one is created automatically by the Supabase. And for the rest, you need to gift name and a gift code. Please pay attention when you create this table. The table name and the column name are the case sensitive, because we write this the URL, write the SQL in the JavaScript, and we hard code this JavaScript in the smart contract. So you need to be attention. This should be the case sensitive, and then input the 3 values into this table. The first one is this one, the second one this one, the third one is this one. And actually, you can write anything you like. This is what I'm thinking is good. Maybe you think other name would be better for you. Okay, when this table is created, you need to create a RLS, the row level security policy. That is nothing but to allow the users to read this table, because there is access control, right? There is access control for this table, and only if the user has API key to this table, they can read the data by select the column, select the record from this table. So just follow this tutorial and to create a table. And after your table is created successfully, and then you can go to the project settings to know the URL of this project and the API key of this project. Let's go to the project settings here. Okay, it should be in the data API. Yeah, for this one is the URL. This is a URL you need to use to read the data, to insert data. And the second one is an anonymous public key. So with this key, anyone can just read or update or remove or do anything to this table. And these two are the credentials you need to interact with the table you have in your Supabase. Okay, I will leave the two informations here. And we finish the first step to create a table here. We create a table in the Supabase and save the gift information in the table. And then we have our URL and API key. So anyone else can just use our key and URL to read the data to this table. Okay, so actually in this workshop, the person who will read this table will be the Chainlink Functions. And the Chainlink Functions will have our API key and to get the data from this table. And we will see how they can use this credential data, because we cannot upload that on chain, right? Okay, let's move on to the second step. Let me check if there's any questions. So the question from Aris. So Eliza is a client we use to connect our user inputs like a Gemini API. Yeah, Eliza has the plugin called, or maybe name is not plugin. The Eliza has a client, and you can use the Twitter as a client of Eliza. And Eliza also has a LLM, and you can use the Gemini API as the LLM. So the Eliza is just a framework to combine this stuff together. And you have a large language model, and you have a client like a Twitter account, and you also have some functions or actions you want the AI to trigger, and you can combine these three stuff together with a framework, and this framework is called Eliza. And there are some other frameworks. The reason I'm using the Eliza in this workshop is because Eliza supports the EVM, and it is very easy for me to use Eliza to send the transactions to the EVM compatible chain like Avalanche. And this will be recorded. And yeah, this will be recorded. And this workshop is a single session, or there will be multiple sessions? It's a single session. Thank you, Kevin. Another question is IPFS is more like a storage rather than a backend database. Yeah, correct. And the question from the SaaS user, can we build these agents on other blockchain too? Yes, you can build agents on other blockchain. And because we are using the Avalanche today, so we are using the EVM compatible chain. So which means that you can build this AI agent on any EVM compatible chain, like a Arbitrum or like a BSC, like this. You can build on other chains. And another question is, I wonder why using Web2 concept, the Web3 concept is necessary. The data could be stored in a file on the IPFS or similar. We will use the IPFS later in this workshop, because if this data is not supposed to be updated or changed anymore, we need to, it is better for me to save this data on the IPFS, because the data, if the data is saved on the IPFS, you cannot use the URL or API key to update this data. It will be just written into a storm. And if we will save the metadata of our NFT in the IPFS. Okay, so let's move on the step 2, the deploy the get gift certificate. So we just finished here, the Supabase table, and the next part is the function consumer smart contract. Sorry. So the smart contract is used to receive the transaction from the AI agent. And then this smart contract also trigger the Chainlink functions to get the data from the database, and then check if the data from this database matches the data input by the user. If that is a match, if these two gift code is the same thing, the functions will mint an NFT for the address. This is what this function do. So for the function, this smart contract do. So for the smart contract, I can just explain this code a little bit first, and then we will deploy it. So as you can see for this smart contract get gift, it inherits from the two smart contracts. The first one is the functions client, and the second one is the ERC 721. The ERC 721 is a token standard for the NFT. And for the function client, we have two functions. The first one is, this one, the send request. And the second one is a fulfill request. So these two functions are used to send and receive the request to and from the DOM. It's as shown in the graph here. When the functions consumer smart contract receive the request from the AI agent, it will trigger a request to the Chainlink functions. And the Chainlink functions will get the data and return the data back to the smart contract. And the send request is used to send the request, and fulfillment is used to receive the data from the DOM. Okay, so it is very simple, the send and receive. And the name is send request and fulfill the request. And another thing need to be notion is that we have this source. As you can see here, it's as you can see here, the source here is hard-coded, and it is a string. And if you check the code here, you will find that that is a JavaScript code. So like gift code, we will get it from the arguments, the first arguments, and then we will check if the API key exists. If not, through an error. And if we get these two necessary information, we can create a HTTP request, right? We have this URI, we have this method as we have a get as a method, and we save the credentials in the headers. Then we will send this request to the run this code to send a request to send the get request to the table, and then we will get the data from the response and to check if we have this if we can have the gift code when we got in the as the first argument here. And when we get this item, if the item exists, we will return that. If not, we will just return the not found. This is a very, very simple HTTP GET request, and we just allow the DOM to execute this JavaScript and to get the data from the Supabase table. Okay, this all I'm talking here is about a function client, this functionality. And the other one is the ERC 721, that is the NFT standard. In the ERC 721, maybe you are more familiar with that. We have a function called mint, I think. Save mint. So if the correct gift code is returned, then we will save mint. We will do the save mint and to mint this NFT to the address. I think it's defined in the fulfill request. Here, it should be here. Right? Yeah, here. So when the gift code go through all the verifications and if everything is good, then we will call the save mint. So when this response comes to the fulfill request to this function, and this function will do some verifications, and if everything is good, we just call the other functions within this smart contract and call a save mint. This is a function inherited from the ERC 721. Okay, so this is the smart contract we are going to use for our workshop. And let me open the remix to deploy that. Okay, in the remix, let me just clear all this stuff. Delete. Okay, I guess all you are the developers in the Web3, right? You should be familiar with remix. It is a very famous and popular online IDE for the Solidity developers. And click this three-point here, and we can create a blank workspace. And we can give it a name like a workshop, maybe March 12th, and OK. So we have a brand new workspace here, and we can create a smart contract called get gift.solidity. And then we paste everything we got from the Gitbook here. And when you paste that, the remix just automatically download every dependencies you need for this smart contract. And let me go back to the Gitbook. Before I deploy, there is attention. So in the pasted code, look for the variable source. And this contains the JavaScript program that the Chainlink Functions will execute. You need to change this one before you deploy. It's here, this one, this URL. Because in this URL, it is the URL here might not be yours. When you create an organization on the Supabase, you will have your unique URL, and you need to replace this one with with yours. And let me check what is my URL. This is mine. So HET something like that. Let me copy that and switch back to the remix and paste it here. And then you need to make sure the name here match the table name you created in the Supabase. And the column name here match the column name you created in the Supabase table. Okay, after you after this check, let me check if there is anything else. Okay, looks good. Let me just compile. Press Ctrl plus S or Command plus S to compile the smart contract, and then go to the deploy tab and select the injected provider. Change that. Yeah. Let me show you my MetaMask. I'm on the Avalanche Fuji testnet. And if you want to use the Avalanche Fuji testnet, you need to switch to the correct testnet on your MetaMask. And you need to also promise that make sure you have enough balance of the native tokens, because when you deploy the smart contract, you need to have some native token on the blockchain. And I have enough tokens, I think. Okay, and then we can click this button, deploy. Did I click again? Yeah, and then the MetaMask pops up. Let me confirm the transaction. Looks like we have successfully deployed our smart contract, and you can see all the functions we create in our smart contract, like where is that? The send request and fulfill and some other functions from the USC 721 token standard. And that's it. We have our smart contract deployed. Okay, I think we have already finished the step 2, the deploy the get gift. And when you deploy this smart contract, just please pay attention, replace this URL. And you definitely need to put your project ID here and make sure the table name and column name are exactly the same thing with when you from here to your Supabase table. Okay, so let me check the chat box to see if there are any questions, and then we can move on. Yeah, looks no questions. Yeah. Okay, let me go to the step 3. And the step 3 is a little bit complicated to understand for now, because it's related to the mechanism of the Chainlink Functions. As we can see in this one, in this part, the storage in the backend. we need to allow the Chainlink functions to send a API call to the Supabase. But the Supabase has the access control. And if you want to successfully get the data from this Supabase, you need to provide API key. But the API key is a credential, it's a secret. It cannot be known by anyone else. How we can allow the Chainlink functions to use our API key, use this credential. The way is to upload this API key to the Chainlink DON, and we have something called, let me check if, well, it is not here. Oh, it's in the step 4. I'm sorry, it's in the step 4. So we have something called DON hosted secrets and off-chain secret. So before we allow the DON to use our secret, there are 2 ways. The first way is to just encrypt our secret with the public key of the DON. There are going to be a lot of the several public keys because every node under the DON has its own public key. And we use all of their public key to just encrypt the secrets and then upload to the DON. Upload this encrypted secret to the DON, and the DON can just decrypt that with enough private keys in this network. And another way is to do the same thing, to encrypt the secret and upload to somewhere. It can be fetched by the DON. So it is a DON hosted secret and off-chain secret. And in this workshop, we will use the DON secret, DON hosted secret. And before we're using that, first, we need to create a subscription for the Chainlink functions. And go to the Chainlink functions, the functions.chain.link. Let me go to the functions. Yeah. Please make sure you have the correct network shown here because we are using the Avalanche Fuji. We click that Avalanche Fuji. And oh, here is it. Yeah, in this UI, the way to create a subscription is just to click this blue button, and you need to provide your com at smartcontract.com. If there is something wrong, we will email you, and you can give a subscription name, but that is optional. And check this box and create a subscription. Oops. Yeah, I confirm. And a signature. Let me check if that is done. Yeah, if you think that is done, you can go to this one, and you can see here, the 15395 is a subscription I just created. And when I click that, you will see that here are actions. In the actions, you can fund the subscription because we want the Chainlink functions to help us to send the API call to the service. So it will spend some money. And the functions need to write the result back to the smart contract, and it costs gas fees. So we need to fund some coins into the subscription. And you can fund with a link token or native token on the blockchain. For now, I will fund like link tokens here on the subscription, and I give it, because I'm so rich in the link tokens, so I will give it 100 tokens. And we need to wait for this transaction is done. Yeah, it will take some time. Okay, it's good. Let's close that. Awesome. And you can see here, the balance is 100 link. And the second, we need to add a consumer. We need to tell this subscription who has the right to use this balance. So we need to add our smart contract address here. So when the smart contract want to trigger the Chainlink functions to send a request, then the Chainlink functions can say, oh, the consumer is here and he has a right to use this balance. So we need to add our address here. So get the smart contract address from the remix, click this button, and switch back to the Chainlink functions, add consumer, click that. Let me refresh the page and add consumer. Oops, why it is not? Oh, here, I'm sorry. So the consumer address and add consumer. So your MetaMask is going to pop up and click confirm to add our smart contract as a consumer under this functions subscription. Okay, close that. So for now, we can see our smart contract is here, and here are some events, the history event. We create a subscription, we found our subscription, and we also add some consumer smart contract into our subscription. Okay, let's go back to this one, and the step 3 is finished. And let me go to the step 4. Step 4 is prepare the DOM hosted secret. And we have already created our subscription and add our consumer, and then we need to upload our secret that is supposed to be used by the Chainlink DON to send a request. And because we are using the DOM hosted secret, so we are going to just upload our secret to the DOM. And you go to this repo, and I have already create a script for users to upload this secret onto the DON. Okay, let me go to the terminal, and here is my path. And for now, this directory is empty. Let me zoom in so I can. Let me clear that, and then git clone. Oh, what happens? Oh, I write 2 git clone. Why there are 2 git clone? Oh, I copied everything. Sorry. Just copy that and paste it here, and clone the repo from the GitHub. And then we have a directory called Eliza Twitter Chainlink Functions. Actually, it is a repo I created here. And if you want to check the source code, you can go to this repository to check what I did for this repository. Actually, this repository, the Eliza Twitter Chainlink Functions, is a forked version of the Eliza starter. And with the Eliza starter, I create custom plugins and some light version of the client. Then we can use it as an agent to connect our Twitter and LLM and also the smart contract. Okay, so let me go back here. Let me go to this directory and open that. Use the code, VS Code. And here are our architecture. All the codes are saved under the source directory, and under the scripts, we have several JavaScript scripts, test DB, upload GIS, and upload to DOM. So what we are going to use is this script, upload a secret to the DON, the decentralized Oracle network. And let me check how to use that. We write it here. So first, we need to install all the dependencies. So go to the terminal, npm install. It will take some time, but let me just keep going. And then we are going to fill all the environment variables. Okay, yep, it's done. Let me go to the VS Code. So in the VS Code, make it bigger. So here you can see this file, the .env.example. It is an example file for the environment variables. So in order to use this repository, you need to at least fill these environment variables. The first one is an API key. So for now, we provide two ways. The first one is a Gemini API key, and the second one is the OpenAI API key. And except for that, because we need to send the transactions, we need an EVM private key, and we also need an RPC port from the Avalanche. And with the EVM private key, you need to save some tokens into your account and provide your account's private key here, and also get a RPC port from the Avalanche, from the Infura or Alchemy, from this service provider. And in the last step, if you want to connect this AI agent to your Twitter, you need to input your Twitter credentials here, the Twitter username and a Twitter password and email and some others. And my suggestion is that you need to create a test Twitter account for this demo, because if something bad happens, or if you don't want anyone else to just find you post some random things, you just use a test account. So you can keep your primary Twitter account no more. Okay, because I have already created my .env file, so I will not fill it one by one. I will just copy that .env file from this one to this one. So I have copied my pre-prepared env file and to this folder. So I will not show you these credentials. I will keep it secret. But if you want to use this one, you need to fill all of these credentials. Okay, cool. So this one is all the dependencies are installed, and the environment variables are created. Let's see what we need to do next. Add the environment variable stuff, and let me see what else. The EVM Avalanche, Supabase private key. Yeah, looks good. Okay, so next one is to run this command to upload our secret to Dawn. Copy that command and paste it here. So for now, the secret is uploaded. It's being uploaded to the DON. Okay, looks like the upload is successful, and there is a new text file created here. So after the secret is uploaded successfully, we have like 3 returned back. The first one is a Dawn secret version. It's like the ID for your secret. If the DON want to get the secret, the DON has to know what is your ID, and it is called a Dawn host secret version. And the second one is a slot ID. It's a random number based on this secret version. And the second one, the third one is expiration time minutes. It means how long this secret expires, because the secret will always expire. And the 1,440 is the number of the minutes until this secret expires. Okay, so we have these 3 key informations, and I think we are good here. Yeah, we are good here. And now let's set up our start Eliza agent. Okay, so this is a very important step, and we're almost done here. And here we are going to combine all of the stuff we did before together by set up the AI agent with Eliza. So first one is to go to this directory we already did in there, and the second one is to fill in all the environment variables. And because I have already created one, so I will not do this. But when you follow me and you come to this point, you need to fill out the necessary information in the env file. And then the third step is to update variables in the action implementation in the getGift.ts. Let me go to this. Customer plugins and actions. So for the getGift, this file is what I mentioned before. That is the action you define for this AI agent. For this action, for this AI agent, I want it to get the data from the database and then to trigger a transaction to mint an NFT. So I need to define what I want this AI agent to do in this file. And in this file, you can see that we have some parameters. For the conveniency and to save time, we just write these variables hard-coded. So if you don't want to do that, if you don't want to hard-code all the variables, you can still to include these variables from the arguments. But for simplicity, I just write it hard-coded these values. The first one is the chain names, Avalanche Fuji. The second one is the contract address. Because you want the AI agent to trigger the functions, you need to tell it which smart contract, what is the address of the smart contract. So let's get our smart contract. It's the same thing here. Just copy the smart contract we just deployed with Remix and come back here and paste it here. So we have our smart contract address. And then we need to tell DUN where to find the secret, the slot ID and the version. You know where to find it, right? Here, the DOM hosted secret version, and copy that. Go back to the getGift. Here, paste it here. Oops. Oh, maybe I didn't copy that. Here, copy that, and go back to the getGift. This is the version. And the slot ID is 0. And for the Chainlink subscription ID, we can get it from here. Here, the 15395. Copy that, remove that, paste it here. So we have the everything we need: the contract address, the chain name, and the secret configurations, and also the subscription ID from the of the Chainlink functions. And then we are already almost done. Let me see what I need to do else. Okay, in this third step. Okay, here. So next one, we can just start our AI agent. Let me go to the terminal called npm start. Yeah, so for now, the service is already being running on the local. So you can just see the REST API bound to the 0003000 and running locally. And for now, you can just input something like you are using the AI. Like say, hi, how are you? And yeah, before when you first set up, it will download a very small LLM locally, but actually you still need to use the LLM API key. So as you can see here, the Google model large. It means that we are using the Google Gemini API key, and here is the response from the agent. Hi, darling, I'm currently deciphering the extension, something like that. I don't know what this meaning. I'm sorry, English is not my native language. Okay, so now we want to get the gift, and let me just input a natural language input to this LLM, like, hi, can you give the send END gift to the address. Let me see my address. Copy my address here. This one. And my gift code is, let me get my gift code. Go to the database. And here, let me try the first one, this one. Okay, this is my gift code input. And for now, we input this natural language input to the AI agent. Then the AI agent will just analyze our input and do the actions. For now, you can see that it knows that we want the AI agent to send a gift to us. And here, it gets the necessary information and return in a structured data type, and then it send a transaction and give us the hash of this transaction. And if we come back to the Chainlink functions for now, let me refresh the page. You can see here is a new request, right? So because the AI agent sent a transaction to the smart contract we just deployed, so the smart contract will just wrap the information that is necessary and send a request to the Chainlink functions. And the Chainlink functions receive the request from the smart contract, and then it will call the API in the Supabase and get the result and run the JavaScript we just modified in the smart contract. And then, if everything is good, the result will be returned back to the smart contract. Okay, let me refresh that again. And you can see here, the status is computation good and a callback good. So if we go to the remix and check the token URI, let me check the token URI for the token ID 0. That would be the first NFT, and check it. You can see here is IPFS address. It is data I saved here. Let me show you. Here, I created 3 metadata as a constant, and this is the first one, second one, and the third one. And this may be not very good to check. Let me go to the OpenSea testnet. So let me click that. Go to my profile. Oh, this one is from the last time. I'm sorry for that height. And so we can see that here is a NFT granted to our address, to my address. I'm sorry. That is from the gift smart contract, and the address of the smart contract is here. It's 622EC10. Let me go to the remix and check if that is the same one. Yeah, 2EC10, that is the same one. So this NFT is just minted to my address because the Chainlink functions get the gift code from the database and put this gift code to the smart contract, and the smart contract here, smart contract will check in the fulfill functions, and because the gift code is cracked and it goes through all the verifications, and then a new NFT will be minted through the safe mint. And finally, we will see this NFT on the OpenSea because OpenSea will automatically index all the NFTs from the existing ERC-721 smart contract. And from the view of the users, the user is just input this one. Hi, can you send a gift to the address here? And my gift code is this one. And they don't need to install the MetaMask. They don't need to know like a smart contract. They don't need to know how to call the functions within a smart contract. They just input this one, type this natural language, and the AI agent will analyze if this one is supposed to be used to supposed to trigger some actions we defined in advance. So the AI agent will say, hey, we see the keyword like send gift, we see the keyword address and a keyword gift code. Oh, maybe this request is to ask me to mint an NFT for him. So the AI agent will get this one, and then it will send the transactions to help the end users to mint a NFT under the smart contract. So this whole process, the AI agent serve as a brain, serve as a very smart backend in the project. And whatever the user input, user need to just correctly click the exact button or just input the exactly correct information. They just input whatever they want. And the AI will serve like a human, like a brain, to analyze this input and do whatever they want to help the users to do the predefined actions. Okay, so this is what we're doing today for the AI agent. And last step is that we will use the Twitter client as the front end to the users, because for now we use this terminal and the user need to input here. This is not good. So we want to use Twitter as a terminal, so users can tweet, make a tweet, post a tweet, and then the Twitter that is represented by the LLM will receive this information and do the same thing and call the functions of the smart contract. Okay. And yeah, before I move on, let me just check if there is questions. So there's a question from Eric. How can I do this with OpenAI API key? Yeah, we will talk it just 5 minutes later. Yeah. And another question is, can you explain how you added a custom plugin to the Eliza starter? Yeah, that is a question I skipped in this step. And if you want to know, I will just give you a very brief introduction. So let me go to the Eliza GitHub. So this one. And under the Eliza OS, I think there is a starter. Let me find there. Yeah, Eliza starter. Actually, I forked this repo, and under the source, you will see here are some folders, the cache, chat, clients, and the config. And if you check my repository under the source, cache, chat, clients, config, and except for that, you can create another folder called custom plugins, or you can name whatever you want. And under the plugin folders, you need to have the actions, providers, templates, and the types. And you can just copy anything you like from the Eliza core repository and modify after you copy that. And in the actions, that is very important. You need to just define this action, what it needs to do. And for this, I defined this function called getGift. And in the getGift, I get these variables. And then I will create a wallet provider and switch to the chains I need to use. And then I will get ABI. You know, ABI is the binary, the binary for the smart contract, and create the contract handler. And with the contract handler, you can send a request. And in the request, you need to input some necessary arguments and then send this request. And whatever you did here, you need to define an action under this folder. And then you actually create a custom plugin, custom action. And after you're done with that, you just don't forget to add these actions here in the index. So because for every plugin you created in the Eliza, you need to make sure that the Eliza core has access, has export from these plugins. So you need to add it here. And then you create a new plugin, new action for yourself. And you can do other things. You can change this code to do other things. Maybe you want to do a bridge, maybe you want to do a transfer, and you can do whatever you like. But for here, what I'm doing is to send a transaction to the smart contract address here, and to call the specific function I defined for the action, and that's it. So that is a way to create a plugin or create a action. Yeah, maybe the process, the development is a little bit complicated than I said, but you can do it with this way. Okay, and another question is, I don't remember. I think this is the same, but currently the process is very complex. In my opinion, Chainlink should try adding secrets from the functions subscription UI. I totally agree with you. I will reflect this to the engineering team that it should be better that we can have the UI to upload the secret, and we don't use the script. I'm on your side. I totally agree with you. And the link address for the Avalanche Fuji, actually you can go to the box.chain.link. And in this documentation, we have all the services listed here. And go to the function. And there is a supported network. It will list all the configurations in the supported network. And let me go to the Avalanche Fuji. Yeah, Avalanche Fuji here. Oh, the link token address is not here, but other configurations are here. Link token address on the Avalanche Fuji. Let me Google that. Link token address on Avalanche Fuji. Oh, Fuji, sorry. I'll go to this one. Address. Fuji. Yeah, here you can find the address. So if you cannot find any configurations related to the Chainlink, you can just Google that, or maybe go to our official documentation, and we have all the configuration in this page. Okay. Yep. Thanks for your questions. All good questions. And another one is using externally hosted secrets. Does it matter who encrypts the secret? Yeah, it does matter, because for the actually, for your question, it does not matter, because the people only need to use the public keys from the decentralized Oracle node. Every node will have its own key, and you use this key to encrypt the secret and upload to maybe the GIST or some other hosting service that can be accessed by the DON, and that's it. You encrypt that or others encrypt that, it does not matter. You only need to use the correct public key from the DON, and you can do that. Okay, cool. So to the last step, that is the most exciting part, to use the Twitter as our client. And let's do it. It's actually quite easy. And yeah, to answer the question, if you want to use the OpenAI, you need to go to this one, the character. So for the Eliza, or for the this AI agent framework, every time when the framework wants to do something, it will use the configurations. And configurations including the LLM API key, including the plugin, including the personality and the biography. I skipped something. if you check the original one on the starter kit, you will find the personality and all the background of this character. You can understand the character as a person. It has a personality. And when you talk with an AI agent, you are talking to a person. So this character holds all the configurations that the AI agent need to use. And for here, we have our plugin, the get-gift plugin. And we also can define the model provider. So for here, like .google, you can use the .openAI. And if you use the OpenAI, the AI agent will definitely use the API key you provided for the OpenAI, the ChatGPT. And the client here, you can use the client.Twitter. But remember, before you're doing that, you need to make sure that in this example file, the Twitter credentials are filled and the OpenAI API key is also filled. And then you can use them and change the configurations of the character. And for now, if you change the client or add the Twitter as one of the clients here, we are now good to use the Twitter as our client. Okay. The same thing. Before I do that, let me just go to my Twitter account. So this is a test Twitter account I created for this workshop, and here is my this one is my primary Twitter account. So as I suggested, you'd better to create a test Twitter account for your project because you don't want other people to see like there is something posted suddenly or there is some random words posted from your Twitter. Because if you want, if you create a Twitter and use the Twitter as a client for your AI agent, then the AI agent will control your Twitter. It will just use the AI agent personality for your Twitter. So for safety, just create a test Twitter account for the project. So for me, the Twitter account I created is S Along Hudson. So my primary Twitter is Along Hudson. So this is a small one, small Along Hudson. So I need to input all the credentials for this S Along Hudson to the environment variables here, right? To here. Okay, so let me start that. npm start. Because for this time, we are using the Twitter as a client. So we will see there is a new tweet posted here. Let me check that. Maybe it is started. As you can see here, it is loading yeah, a little bit slow because it need to, as the AI agent need to access the Twitter with our credentials. Let me refresh. Yeah, as you can see here, the 14 seconds before a new tweet is posted here. The AI agent starts at this time. I'm sorry, this time is a China time zone and maybe different from yours. But it means that we successfully start our AI agent, and this Twitter is just a wrapper of this AI agent. Okay, so cool. So how we can interact with the Twitter? We can create a post and tag this Twitter. Along Hudson. Let's see. Hi, can you please send the gift to the address? This one. Let me get my address again. Post here. My gift code is, and I go back to the Supabase. Because we have already used that one, this is redeemed. This cannot be used again. I set this limit in the smart contract, so we need to use the second one. Use this one, copy that, go to the Twitter. Oops, where is my Twitter? Oh, this one. My code is this one, and post. Okay, so for now, we just post this new tweet and tag this bot, this AI agent. And then when we check our backend, we can see that, yeah, it is checking. So this sentence is detected by the AI agent, right? You can see this in the backend. And then it uses LLM and to analyze that, and the get gift action is triggered, and then it will get the necessary data, the information data, the important data from that natural language, and send the transactions to the blockchain. Okay, let's go back to the Twitter and refresh that. You can see here, under this tweet I just posted, and the AI agent just replied, successfully called the function with a parameter of the gift code, this one, and the transaction hash is provided here. So with this, you just, you just don't need any UI. You don't need to develop the front end of the website. You just use this Twitter, and you can wrap your AI agent with this Twitter, and you can also create a variety of the actions for your AI agent. So you can allow your users to interact with your Twitter account and do whatever you defined before. And this is so cool, right? Because it defines a new form of the front end. Because like the old Web2 app, the user need to input something in exactly the text box, and the user need to click the correct button, and the user need to do the correct things. Then this request can be understood by the backend. But with the Twitter, with the AI agent, actually it is blurred. Users can just input anything they want, and the AI agent will like an employee of you to just handle this information. And if this actions is defined, and then the AI agent will just do whatever you defined and help the users to do the correct actions. So this is the AI agent. This is the abstraction layer I mentioned before. Yeah, this is so cool personally, and I hope you can just enjoy it and to build your AI agent, just give it a shot. And yeah, let me go to the OpenSea to see if I have the second one. Profile. Yeah, ta-da, this one, the $50 discount gift. So what I only need to do is to just in the Twitter, so input this one, and after that, I will get a gift for that. I don't need to know anything about a smart contract, anything about a Chainlink. I just input whatever I want to in the natural language, and then we got the gift. And yeah, that is the whole presentation, whole workshop today. I hope you enjoy it. And if you have any feedback or have any more questions, just comment. And this workshop is recorded, and you will see that on the Chainlink official YouTube channel. And I hope that you enjoy that. Cool. And yeah, let me check if there is any questions. Yeah, looks good. Looks you all get it. Yeah, cool. Thank you. Thank you so much. Thank you, guys. Hope you have a good rest of the day. And let me end the stream. Thank you, guys.